tangent of theta, let me get a different color, plus the cotangent of theta is equal to the secant of theta times the cosecant. Oops. Let me erase that. Cosecant of theta. We're going to start with the left side, this one right here, and I want to work things until I end up with the right side. My trick is to go to reducing everything to sines and cosines. Tangent of theta is equal to the sine of theta divided by the cosine of theta. The cotangent of theta is equal to the cosine of theta divided by the sine of theta. Now I have two fractions. This one here has a denominator of cosine. This one here has a denominator of sine. I need a common denominator, and that denominator is the product of the cosine and the sine. So I'm going to write that next. Here's my common denominator, sine of theta times the cosine of theta. On top, I have on my left side what I don't have here in this denominator. I need to put in, and so I'm going to multiply both top and bottom by sine over sine. Now I get sine times cosine on the bottom, and on the top I get sine squared of theta. Over on the right hand side, I have sine of theta on the bottom, but I don't have cosine, so I'm going to multiply by cosine over cosine to get that. Now I have the common denominator sine of theta times cosine theta. On the top I have plus cosine squared theta, which is pretty nice because you'll recognize this guy as that Pythagorean identity, which is equal to 1. So this whole thing now becomes equal to 1 over the sine of theta times the cosine of theta, which is equal to 1 over the sine of theta times 1 over the cosine of theta, which is equal to the cosecant of theta times the secant of theta. And we just flip those around because we're just multiplying them, and we have done it. We've shown what we needed to do. We have proved the identity.